Assalamualaikum and hi everyone. Topic 10, Application of Differentiation, Lecture 1 of 3, Part 4 of 4. At the end of the lesson, students should be able to A. Find the point of inflection, B. Sketch the graph of a polynomial function up to degree 4. Okay, now we continue with the next example. For the function fx equals to x to the power of 4 minus 8x squared, find A. the stationary point, B. the interval where fx is increasing or decreasing, C. the relative maximum or relative minimum point, D. the interval where fx is concave upward or concave downward, E. the point of inflection, and hence sketch the graph of fx. Okay, so for the first one, for the function fx equals to x to the power of 4 minus 8x squared, we need to find the stationary point. To find the stationary point, we need to differentiate fx, that is equals to 4x cubed minus 16x. To get the stationary point, we must equals to 0. Factorize 4x times x squared minus 4 equals to 0. We get x equals to 0 and x squared minus 4 equals to 0. Simplify to get x equals to plus minus 2. Okay, to get the point, because the question asks to find the point, we need to find what is fx for x equals to 0, 2 and negative 2. When x equals to 0, fx equals to 0. When x equals to 2, fx equals to 2 to the power of 4 minus 8 times 2 squared. The answer is negative 16. And when x equals to negative 2, fx equals to negative 16 also. Therefore, the conclusion is the stationary point are 0, 0, 2, negative 16, and negative 2, negative 16. So, that is the answer for A. And B. B, the question asks to find the relative maximum or minimum. Okay. To find the maximum and minimum point, we need to do the first derivative test. So, the first derivative test, normally, we write in the form, we find the conclusion in the form of table. So, we draw 4 rows here. For the first row is interval. From negative infinity to infinity, we have to create 4 columns, that is negative infinity to negative 2, negative 2 to 0, 0 to 2, and 2 to infinity. As usual, we need to substitute the suitable value in the interval, within the interval, into f prime x. Okay. So, when I substitute negative 3 into f prime, the answer is negative. Substitute negative 1, the answer is positive. Substitute 1, the answer is negative. Substitute 3, x equals to 3, f prime x equals to positive. So, this is the conclusion. This is the conclusion for fx. Therefore, our function fx is decreasing. Negative means the function is decreasing. This is the shape when fx is decreasing. Positive means fx is increasing on the interval from negative 2 to 0. on the interval from 0 to 2, the function is decreasing, and from 2 to infinity, the function is increasing. Fx is increasing. So the conclusion is fx increasing in the interval from negative 2 to 0 and 2 to infinity, and fx decreasing in the interval from negative infinity to negative 2 and 0 to 2, decreasing on this interval. So that is the conclusion for the interval where fx is increasing and decreasing. Okay, see, now we can conclude what is the relative maximum and minimum from the table. From the table, there is a conclusion there, that is from negative infinity to negative 2, the function is decreasing. From negative 2 to 0, the function is increasing. Means there is one point here. Negative 2, at the point x equals to negative 2, we have minimum point. At the point x equal to 0, we have maximum point. And at the point x equal to 2, we have minimum. Okay? So our conclusion is we have relative maximum at 0, 0, and relative minimum negative 2, negative 16, and 2, negative 16. So we have two minimum point. This is minimum point, and we have one maximum point here, maximum point. Okay, so you need to draw the table, and this table is called first derivative test. Okay, now D. Find the inflection point. To find the inflection point, you need to do the second derivative and equals to 0. So differentiate one more time, we get f double prime x equals to 12x squared minus 16 and equals to 0. X squared equals to 16 over 12. X equals to plus and minus third 4 over 3. Simplify third 4, we get x equals to plus minus 2 over third 3. Okay, so to get the point, we need to substitute these two values to get what is fx for each x. Okay, but before that, we need to test for f double prime first. Okay, so from our two value of x just now, x equals to negative 2 over 3, 2 over third 3, and another one, x equals to 2 over third 3. This is the real number line. From negative infinity to infinity, we have three intervals to be tested. That is negative infinity to negative 2 over third 3, negative 2 over third 3 until 2 over third 3, second interval, and third one is 2 over third 3 until infinity. Okay, so we substitute the value in the interval. For the first value, I pick negative 3. Okay, substitute negative 3 into f double prime. Okay, substitute negative 3 into f double prime. You will get the answer is positive. The answer is positive. The answer is positive. Okay, and when I substitute 0, the answer is negative, and substitute 3 into f double prime, the answer is positive. So what is the conclusion that we can make for fx? fx concave upward. When f double prime is positive, means fx concave upward. Positive. When f double prime negative, means concave downward. And from 2 set 3 until infinity, the function concave upward because f double prime is positive. Okay. So this is the table for f double prime to determine the inflection point. So when the value of f double prime change from positive to negative, and from negative change to positive, we can say that this number, that is x equals to negative 2 over set 3 and x equals to 2 over set 3, is an inflection point. Okay. So the interval where fx concave upward is this one. That is negative infinity until negative 2 over set 3 and 2 over set 3 until infinity. The interval where fx concave downward is from negative 2 over set 3 until 2 set 3. Okay. Now we continue to find the inflection point. Okay. As usual, you need to find what is fx for x equals to 2 over set 3 and x equals to negative 2 over set 3. Substitute into the function fx. You will get the answer is negative 896 over 81. Same as when x equals to negative 2 over set 3, fx also equals to negative 896 over 81. So our conclusion is the point of inflection are these two values. Okay, negative 2 over set 3 for x and y is negative 896 over 81, and 2 over set 3 negative 896 over 81. Okay, because the sign for f double prime change from positive to negative and negative to positive. Okay, lastly, to sketch the graph. To sketch the graph, you need to find x and y intercept. Okay, you need to find x and y intercept. So for the function fx equals to sketch the graph, we need to find x-intercept and y-intercept. So for the function fx equals to x to the power of 4 minus 8x squared. So when x equals to 0, y equals to 0. To get x-intercept, y must equals to 0. When y equals to 0, what is the value of x? We get x equals to 0 and x equals to negative plus minus set 8. So x-intercept is set 8 0 and negative set 8 0. Okay. Then we continue to sketch the graph. Okay, so we continue to sketch the graph. Take a look at the first derivative test, that is this table. We can see that from negative infinity, to negative 2, the function is decreasing. Okay, the function is decreasing. So from negative 2 to 0, the function is increasing. From 0 to 2, decreasing. And from 2 to infinity, the function is increasing. So to draw the graph roughly, the function is decreasing from negative infinity until negative 2 and passes through the point negative 8, 0 and negative 8, 0. So means this is the minimum point, negative 2, negative 2, negative 16 and 2, negative 16 is the minimum point. So if we draw a line, the graph will be like this. Negative 2, negative 16 is the minimum point. Then from negative 2 to 0, the function is increasing. From negative 2 until 0, the function is increasing. So from negative 2 to 0 here, from negative 2 to 0, the function is increasing and passes through this point. The point negative 2 set 3, negative 896 over 81. So if we draw a line, the shape is like this. Okay, but we need to include the concavity. So you need to consider concavity here by using the second test table, double prime table. So from negative infinity to negative 2 set 3, the function is concave upward. Okay, so from negative infinity to negative 2, we know that the function is decreasing. The function is decreasing. What about concavity? For concavity, from negative infinity until negative 2 set 3 means here the function is concave up. Okay, so from negative 2 until 2 set 3 here, the function is concave down. This one is down. And from 2 set 3 until infinity, the concavity is up. Concave up, this one concave down, this one is concave up. Therefore, I will consider the first table and the second table to sketch the graph. That is, the function fx is decreasing and the concavity is up. Okay, so means you have to draw from negative 8 set 3 until negative 2, the function is decreasing and the concavity is up, concave up. Okay, and from negative 2 set 3 until this point, the function is increasing and the concavity is still concave upward. Until the point negative 2 set 3, the concavity is upward. So the graph is increasing. How to draw the shape of the graph is increasing and concave upward? The shape is like this. Okay, from negative 2 set 3 until 0, negative 2 set 3 until 0, the function is increasing and the concavity is concave downward. Okay, here the concave downward. So you need to draw like this. Okay, so that's on the right side. From 0 to 2, the function is decreasing and the concavity is concave down. Okay, from 0 to 2 set 3, the concavity is concave down and the function is decreasing. So the effect passes through the point 233 and negative 896/81, decreasing and concave down like this, and we continue from 0 to 2. The function is decreasing, so decreasing and concave upward, concave up. From 2 to infinity, the function is increasing, and the concavity is concave upward. So increasing and the concavity is upward and passes through the point 80, the x-intercept. So the shape is like this, and you need to delete that one, and I will join the line. So this is the shape of the graph. You need to consider the first test, that is the graph is increasing or decreasing, and you need to consider the concavity of the function, either concave up or concave down. You cannot draw a graph with a straight line without consider the concavity. So when the graph is increasing and the concavity is up, is like this. Okay, if the graph is increasing and the concavity is concave down, the shape is like this. Okay, this one is concave down, this one concave upward. Understand? Okay, thank you. Okay, from the graph we can see that we have two minimum point here. There is point A and a point B is a minimum point or minimum relative. We have one maximum relative, that is point C, and we also have an inflection point, that is a point D here, and point E. Okay, take note that an inflection point is a point where the concavity change from concave up to concave down, or the concavity change from concave down to concave up. So D and E is called an inflection point. Okay, D and E is not a minimum or maximum relative, but we call it an inflection point where the concavity change. Okay, that's all.